All right, we're picking back up to finish up lesson 2. There's 2 more proofs, and again, I told you guys I would walk you through these. So let's look at what we've got here. We've got a couple of blanks we have to fill. So this shouldn't be too tough. So let's follow through. We've got a quadrilateral ABCD. We see that A is supplementary to D and A is supplementary to B. Remember, supplementary, when it says that, supplementary means that they add up to 180 degrees. So that's important for you to remember. So this 180 is key. So let's look at what they have here. So we have this information given. Then it says BC is parallel to AD. So it says, think of AB as a transversal cutting BC and AD. So let's look at BC, AD, and we have a transversal of AB. What kind of angles are angle A and B? So angle A and angle B. There's 2 angles. So these would be same side because they are on the same side of the transversal line. And they are both interior. So we look, there we go, same side, interior angles. Now the only other options that make any sense is going to be alternate, but these are not alternate. They're on the same side of the transversal line. So that's where we get that one from. All right, let's keep going. Let me erase. A is supplementary to D, that's given. And then we do the same thing. It says, think of AD as a transversal cutting AB and CD. There it is. And then what do I have? I have this angle and this angle. Those are, again, same side interior angles. So we're going to go down and select the same exact one, same exact concept. And that is literally all they have us do on this one. You just have to know that these are examples of same side interior angles. So that's really pretty easy. Let's jump down here. Okay, a lot more to do in this one. It says, prove that ABCD is a parallelogram. Okay, what are we given? We're given a quadrilateral ABCD. It's this guy. And we are given the fact that AE is equal to CE, that's this and this. And we're given that BE is congruent to ED. So those are the diagonals. So if I go back to my lecture notes, I'll notice that that's what we have in 6.2e. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So that's what we're trying to prove here. So let's see what we got. So AE is congruent to CE, BE is congruent to DE. That's a definition of what? Well, this, bisect. Definition of a bisector. So let's see where that is. Definition of a bisector. Okay, midpoint. Now I got a little bit ahead of myself. Midpoint is directly connected to the idea of bisecting because a bisector cuts something in half at its midpoint. So that's where that's coming from. So I'll erase that. And that's where we're getting definition of midpoint, which is I. Oh, that's very confusing. Super annoying. All right. Next one. AEB is congruent to DEC. That would be AEB, that's this angle, would be congruent to DEC. I just did that backwards. Sorry about that. That's this one. And this one. And it says AED is congruent to BEC. So those pairs of angles are congruent. Those are called vertical angles. It says, hint, what kind of angles are they? They are vertical angles. Vertical angles are when you have 2 lines intersecting and you look at the angles that are here and here, and of course the angles that are on the other part here and here. Those are called vertical angles. Very important geometry concept. I would write that down, draw that diagram. Vertical angles. So we go down, we look, we see vertical is E. So we've used up this, we've used up E. ABE is congruent to CDE. That's the triangles. So we have the triangle, and then what triangle is going to be congruent to the other one? So ABE, that's this one, is congruent to CDE. So then obviously the other triangles would be BEC, and which one? AED. So let's go here and see if we have that. And we need to look for AED. There it is, A or DEA. They did a different order. But look, you only really have two choices that make any sense. You have this one and this one. All right, I had to restart the video. I had a little bit of an issue with the tools going away. So let's get rid of that. Okay, the last thing I had said in the previous video was that DEA was our answer for our triangle. Make sure you caught that. So that's why we have H for the triangle. And then it says angle 1 is congruent to angle 3, angle 2 is congruent to angle 4. Almost any time you prove a triangle is congruent in a proof, the next thing is going to be that C, P, C, T, C. I talked about that up above. That's almost always the next thing. So G is going to be C, P, C, T, C, because we are taking this proof of this triangle and we are applying it to the angles and saying, okay, because those triangles are equal, then the angles are equal. And then we have to ask the question, what type of angle are those angles? Well, 1 and 3, along with separately 4 and 2, are what we call alternate interior angles. We did that above. We've actually used that many times already in this lesson. Alternate interior angles. And so we look here and we can see that we have alternate interior is D, and so that completes our proof. So this is kind of a long video, a lot of proofs, but make sure you do the ones I left for you to do yourself. And I will see you on our next video.